Hi, good afternoon. Welcome to today's webinar with Access Point Consulting. Today we're going to have a discussion with app modernization. With me is Joe Bruffy. Joe, would you like to take a moment to introduce yourself?
Yeah, sure. So my name is Joe Bruffy. I'm the Chief Technology Officer for Access Point Consulting. I've been in the IT field for over 25 years, in security for almost as long, and recently I've been developing applications with Access Point Consulting to help modernize SOC and other threat intelligence platforms.
And I'm Scott Pack. I'm the Director of Security Engineering with Access Point Consulting. I've been working in a primarily full-time security role for about 20 years now, with a background prior to that in systems engineering and infrastructure management, really working to build those tools with integrating security systems with other business interests and a large number of market verticals. And so today we're going to be, like I said, we're going to be talking about app modernization, the for the full stack from where we are to really what we do when we're done. So one big part of that is the gorilla in the room of artificial intelligence. Everybody's selling it, everybody's pitching it, everybody's talking about it. When it gets to that point, sometimes it feels like maybe there's more marketing than there's actual content. But as we modernize our services and applications, there really is a very large positive impact from artificial intelligence. So I'd really like to hear some of Joe's thoughts on what he thinks that role is and how he thinks we might move into it in the future.
And thank you, Scott, for handing that off. And you're correct that most things do seem overhyped. Same thing happened with PCI Express and USB, where there's very few devices for it originally, and then now everything plugs into USB. There's a PCI Express card for everything, and there's even more lanes for those than there used to be. So most people see AI as just the LLM and the chatbot, but there's so much more to it. With today's new decision models and the deep thinking models, it goes well beyond just the old machine learning models, which are still very applicable today. They're very good for pattern recognition and everything else. So you could feed it entire networks of data and ask it questions or have it just watch for anomalies and whatnot. And so the less looked at side is the administrative and operations. So like the AI powered analytics, predictive maintenance, automated testing, intelligent automation, code generation inspection, and much more. We're even looking at using it today to help modernize SOC operations and act as kind of an extra intern or a fleet of interns, really, because the AI is going to become uh, much larger in the future. Because why would you have 100 spreadsheets that you have to combine for a report when you can just have your AI do it, or just ask it a question and it makes that report for you? So, of course, as important as that is, you need to make sure you choose the right strategy. Scott, do you want to talk about that?
Yeah. So one of the most critical components of any type of design or migration is really the planning. It's there are a lot of us that come from a more engineering or more technology background can get kind of frustrated with all the useless talking that we do at the beginning of the project. But really the longer term it is, the deeper you get into it, the more crucial that initial planning really is. And there's a whole lot that goes into that. We really have to think about what's going to be the impact on the user, not only from how are they working today, what's their business process like, um, what what features do they actually use of the current products, but also what would they like? What do they need to be able to do? What's missing from the current product, or what are they working around to make their actual business work? And then combining that with what's the actual business requirements. The one thing that I've jokingly said to people on a number of occasions is, what is the problem that we're trying to solve? That as technologists, it's easy for us to come up with a solution and then find the problem to fit it. But what we really need to be doing is reminding ourselves that that's not the right approach. That we need to look at the needs of the business and how can we make sure that these systems fit with the business objectives, and then build out the technical requirements to fit it. And then especially since we're we're typically talking about migrating to cloud when we talk about modernizing applications. And that brings up a whole realm of new possibilities, from data governance, data loss. We also have to think about the fact that when you involve a cloud vendor, there's not as many guarantees about where your data may actually live. So when you upload a document, does it live in the United States, or is it being shipped overseas somewhere? When it's a data center in the building down the street, you know exactly where it is, but you really have to take into account where it's going to go and how you're going to protect it when it gets there, when we're talking about these types of solutions. And then once you kind of had all those conversations and gotten all that information together, that's when we can really start building out our roadmap, the actual implementation plan of the project, and start the actual, from the technology standpoint, the meat and potatoes of getting the job done. And of course, once we get all of that information collected and we really want to think about how we're going to go about accomplishing this migration, we really have a whole slew of different options to choose from. There's the classic forklift or lift or shift, or what we're calling here rehosting, which is really just taking what you have right now, doing the bare minimum to convert it to the new formats, and just putting it where it needs to be. So in the old times, we would call, like, a good example of that would be a P2V, or a physical to virtual migration, where we had a physical server. We just converted that into a virtualized version of it without changing any of the underlying operating system, what applications are installed, where data is stored, so that while some changes were made, primarily around the hardware and drivers that were in use, by and large, it was virtually identical to the older version, so that we could have the least impact on the application and its usability. Sometimes when we're doing these migrations, it like you might already be working with a cloud application that doesn't really need to be migrated so much as it just needs to be enhanced, or that there could be, like, if you're doing software development on your own, there could be like a newer version of a framework that you just need to make some minor changes to. So that's where we really look at the refactoring aspect, where we're taking the code that we've developed, or the configurations that we have, and just making whatever changes we need so that it fits with the newer versions of software that are being used, or the newer versions of frameworks, or if the cloud providers themselves are making changes. So, for instance, AWS has created or they had developed an older version of a web application firewall, a WAF, and then made changes to what they call WAF v2, which adds new features. It operates slightly differently, but in order to migrate, you have to make a few changes. So, like, that would be an example of refactoring, how we can update it to work in the modern without changing any real deep functionality or usability. The so the way we think about how the different components work together, the actual architecture, sometimes the individual pieces may be good. They may work in the modern environment, but the actual connections between them is a little outdated. We may have to, at that point, that's when we really start talking about the re-architecting aspect. So like, one example of that would be if we have a web application where the data is stored on the same system as the website, as the web host, that it's all one vertical stack where everything sits. But we could re-architect it into something where maybe the data is stored in a database that's not accessible to the user. The web server itself is sitting in a slightly different network space so that we can, and at that point we're kind of decoupling the pieces so that so they can work in a modern design, a more modern framework without actually having to make significant underlying changes. We're just slightly changing the actual architecture on paper. I mean, sometimes we get to the point where we need this application, we need this service, but it's so old, it's been sitting around for so long that there's not really any reasonable way to do a migration or to uplift it. So at that point, we just have to completely rebuild it from scratch. That we may be looking to use some of the same software components or the same hardware components. But we definitely want the same usability, the same features, but we can't. It's the classic problem of you can't get here from there. We can't get there from here, where we need to not only just not only modernize some aspects of it, but just rebuild it from the ground up. I mean, but then sometimes we get to the point where we realize we don't need to do this anymore. That that when we first started using this service, we first started using this application, yeah, it didn't exist, so we had to build it ourselves. But over time, new companies come in, new people get involved, and now all of a sudden, the there's a SaaS provider that provides something that does the exact same thing, and that then we can completely tear down what we've done and just import our data into their systems and then just pay them to do it for us. So then we don't have to build it ourselves. We can just replace it with something off the shelf. And where do we go from there? I know, Joe, this is something that you have done significant work on in your career. What what are your thoughts on how we actually decide what to select?
Well, yeah, there's a lot of things to consider. Obviously, you have your entire strategy and, picking whether or not you need, you're going to rehost or you're going to put it on Google or you're going to put it somewhere else. You're going to build your own private cloud. You're going to work with hyper-converged architecture or you're going to do a dynamic architecture, and all that kind of thing. As far as the platforms go, I mean, typically people use, Azure or AWS or Google Cloud, private or hybrid, as I was just talking about. But once you choose that only tells you what platform it's on. There's also several different ways that you can handle the application. You could do a more modern approach using, containers such as Kubernetes or Docker. You could use microservices. You could also, do a lift and shift and run a virtual server, and they have the architectural considerations of, okay, do I need a load balancer? Do I need to have a WAF? Do I need, what do I need to make this run? There's the data structure. What databases do you need? Are you going to be using AI for, retrieval augmented generation or RAG? You need a different database type than a classic database to run that. A lot of times there's a plugin, like PG Vector on Postgre, but not all support that. And then there's unstructured data, like Excel and everything else. And do you want something like Microsoft Data Lake to tie that together or some other platform because you're using multiple clouds? Of course, you need a way to deliver this as well. So it gets into your DevOps practice and tools. So, you have your constant innovation, constant delivery, your CI/CD pipelines, your software, delivery or development lifecycle, your code repositories. Are you going to store it in Git? Are you going to store it in something else? Code scanning, both at rest or for SAST. That's your static. And then there's DAST, which is dynamic, which actually tries to more or less simulate hacking your site or check for vulnerabilities in real time. Then there's API management. Your old application, you have some APIs that are exposed, but you have to expose all or none. Well, there's a solution to help with that. You can require authentication first to even show that, as kind of a front door. So you use Microsoft APIM and limit what can be used, or Postman or Apogee even. And of course an AI that can be used in your automations, natural language processing, and more. And after that, you have implementation, which is your execution of strategy. And that's obviously a very important step. All right. So during your execution of strategy, you need to set up your infrastructure. You have all the plans and all the documents that show you what you need to do, and all that planning will make it real easy to actually deliver the infrastructure. And once you have the infrastructure up, you can start migration of your data and move it into the correct places, making sure that you don't have any downtime, or and you can mitigate your loss using those loss mitigation strategies. There's security and compliance, which you can build right into the data migration. You want to make sure you set up all your groups and everything else, and make sure that you have all the DLP rules set up so you can recognize any kind of data that or sensitive data you want leaving the organization in case it's exported. And of course, there's the testing and quality assurance. So, once you have everything built, you have to make sure that it works before you start rolling it out. So the constant delivery model, that you're going to write new features and have a feature release, and not necessarily replace the entire application every time. Yeah, that's a lot quicker than the old methods, and usually more effective. But yeah, you have to make sure that everything still works. So you can start with your dev and test, move on to your quality assurance, and then to your end user production.
And then once we get to the into production, then that's typically where the engineering to operations handoff occurs. And all of us who are involved in design and build can very happily step away and go build something new. But then on the operation side, those people that then have to run it ongoing, there's, again, just like with everything else, a lot of the concepts can map, but there's still a lot of additional considerations we have to take into in the more modern environment. So, of course, we always want to really look at performance monitoring, both from a cost management standpoint, that we'll discuss a little bit later, but then also from a resource consumption, because something that we tend to do in more modern designs is under provision resources so that we have a smaller footprint, and then burst when we actually need to. And knowing when we need to have those scale up events where we add additional resources, it involves a, a rather continuous monitoring and investigation cycle to look at not only how we're using the systems in the short term, but then over the long term. We also need to continue along with our software for development, our software work, to make sure that any updates that we're rolling out, any work that we're doing, is deployed correctly. And this really ties into the containerization piece that Joe just mentioned a few minutes ago, where in a more modern and more containerized world, it's not so much we install a software update like we're accustomed to. We can, instead of applying a software update, we can roll out a new instance of the application or service, and then remove the other one, and we have a consistent user experience with no downtime, but still making those updates actually happen. But then all that's great, all that continues working. But something that very frequently happens in cloud environments is our cost overruns. It's very easy to deploy a service, to launch a new application, and then just kind of forget about it. And that's going to continue to rack up bills over time until eventually somebody from finance either comes and yells at you, or you do some kind of monitoring. There that can that in and of itself can be a very complicated scenario, to which we've devoted an entire other webinar to. But but making sure that you work with your operations teams to set those billing thresholds and to actually monitor your spend over time is a very important part of the post implementation of the operationalization of your environment. So with that, I'd like to thank everybody for joining us today. Again, this has been Scott Pack with Access Point Consulting, and my dear colleague Joe. Joe, do you have any final parting thoughts before we leave?
Yeah, I just wanted to thank everyone for watching. And yeah, just to touch on the cost management, I mean, that can also be a way to find what the cost of, say, improving a certain feature might be, or a reason to increase your architectural spend. Because you can easily save money with that. But yeah, like Scott said, we have a whole webinar just about that.
Okay. Thank you for joining us, everybody. Have a lovely afternoon. We'll see you next time.